Hi everyone, let's work on 7.6 sinusoidal functions as mathematical models homework. We're going to look at the first problem here. Finn sat on a deck of a river steamboat. As the paddle wheel turned, a point on the paddle blade moved in such a way that its distance d from the water surface was a sinusoidal function of time. So let's just look at this image. This is an example of a steamboat, image of a steamboat, and the paddle wheel here. If you consider one point on the wheel, as the wheel is turning around, the point is also turning around. And at each time, the distance of the point from the surface of the water is called d, and it's a sinusoidal function of time. So this is what we know so far. When its stopwatch reached 6 seconds, the point was on its highest feet above the water surface. So 6 seconds, 15 feet is the highest point. The well's diameter is 18, and notice that part of the well is always under the water. So look at this shape here. The part of the water is under the part of the well is under the water. So if the diameter is 18, this point to here, part of that diameter is above the water and part of that is under the water. And it completed a revolution every 14 seconds. One revolution every 14 seconds means the period of the function is 14. Now we're going to sketch a graph of the function. So we know because this is sinusoidal function of time, distance is the sinusoidal function of time, the y-axis represents d, or distance, which is in feet, and the x-axis represents time, t, which is in second. So this is what we know about our coordinate plane. When the stopwatch reads 6 seconds, so when time is 6, the distance is 15, which is the highest point. So here is the first point, 6 and 15 is the first point. The diameter is 18. That means from the highest point, which is 15, we need to go 18 down to get the lowest point, which is under the water. So 15 minus 18 gives us negative 3. Okay, 15 minus 18 is negative 3. That's the lowest point. It completed a revolution every 14 seconds. So one revolution on a sinusoidal function, if you consider, let's say, this as a sinusoidal function, one revolution is always one period of the function, which is the distance between two high points or two low points or every other midpoint. These are all one cycle or one period of the function. So if I already have one high point, the period of the function will be 14 seconds after that, and we're going to have at 20, we're going to have another high point because this is one cycle. And we know that between two high points, always a low point happens, which is right in the middle between these two. So the middle between 6 and 20, add and divide by 2 is 13. Here at 13, we have the lowest point at negative 3. So we're ready to graph the function. It's going to be something like this. Now we want to write an equation for the sinusoidal function. So we know that general form is y equal to c plus a sine or cosine of b theta minus d. So a, b, c, d are the values that we need to find. The y and theta are basically representing the d, and theta is the time. So when I'm writing my equation, I'm going to change them as d equal to d is basically the y value. And then instead of theta, I'm going to use c. So let's start with c. C value is the sinusoidal axis, horizontal midline of the function. So this line. Where's this line? We need to find a midpoint between 15 and 6. So 15 plus -3, midpoint between 15 and -3. Divide by 2, that's going to be 12 divided by 2, which is 6. So here at 6, we have the horizontal midline, which is the C value. Then we need to find A, which is the amplitude. Amplitude is the distance between highest point and the midpoint. From 15 to 6, that's 9. Now, do I want to find a sine function or cosine? That's up to you, but look at the one which is easiest, basically. And here we see that a cosine function is ready to use here, because cosine starts from a high point. So I'm going to use cosine function. What is the b value? B value comes from the period of the function. We know that period of the function is period of the parent function, 2 pi divided by b value. Why am I using 2 pi? Because mostly on word problems, the real world situation word problems, we use radian, not degrees, unless it's told to use degrees. So that's why the period of the parent function is 2 pi. And period of this function, as we said, it was 14. So that's equal to 14. Now I can find the b value. I can set a denominator of 1, cos multiple b times 14 is equal to 1 times 2 pi, then divide by 14. 2 divided by 2 is 1, 14 divided by 2 is 7, so b is pi over 7. So I'm going to write pi over 7 here. And then I'm going to write t instead of theta, I'll write t because that's what the x-axis is representing. And d value is where your function is starting, or basically it's the phase shift. So this function, instead of starting from here, is starting from this point, which is at 6. So I'm going to write minus 6. So this is the function. Next part is asking what was the height of the point when Hawk started his stopwatch. When he started the stopwatch, it was basically time was equal to 0, and that's this time. So we want to know what is the height of the point at this point. So all you need to do is to set the time equal to 0 and enter that into this function. So I'm going to use my calculator. You go to y equal, and here enter your function. 6 plus 9 cosine. As you see, a parenthesis is opened now. So I'm going to use fraction to write pi over 7. And then I'm going to open another parenthesis. Notice this is a little bit different from what we write. On the calculator, we need 2 parentheses. And then I'm going to write x, or the variable, whatever is the variable, minus 6. And close 2 parentheses. Don't forget about the 2 parentheses. Now we should be ready to graph the function. Okay, so let's see the graph. This is the graph of the function. Of course, because this is a sinusoidal function, it's going to continue itself from the left and the right. We're looking at part of the function. Now let's make the window a little bit bigger. I'm going to make the y a little bit bigger. Y max, let's make it 25, because right here on the function, we had 1 cycle until 20. So that's why I made the x 25. I can make the x min smaller, -5. And you see, so the part of the graph that we were talking about and we graphed on our notes was this one, from here to here. This is what we did. And then we need to find when the x was 0, what was the distance? Where was the point on the wheel? It looks like it's around maybe -2, but we need to find the exact value of that. So how do I find that point? We go second, trace, and go to number 1, value. When x is 0, so enter 0 here and enter that. it's negative 2.1 something. Okay, so I'm going to write that here. The distance is negative 2.1, which is below surface of the water. Okay, now the next part says how far above the surface was the point when Huck's stopwatch read 20 seconds. So this time, looking at this graph, when the time is representing 20, we want to know what is the distance of the point from the water. So when time is 20, maybe around here, that's this point. It's probably the highest point. It's definitely the highest point, but we're going to try that just to make sure. You go second, trace, and value again, and 20, and it's 15. That's the highest point. And we already got that here. When x is 20, y is 15, which is highest. So time is 20, distance is 15. That's the high point. Next part says, what is the first positive value of time at which the point was at the water surface? At that time, was it going into or coming out of the water? So let's look at the graph. It says, find the point, the first positive value of time at which the point was at the water surface. So we said the x-axis is the water surface. The first time that it was at the water surface was here, this point. So somewhere around 1, but again, we want to make sure. How do we do that? We already have the y value here. We need to know the x value. So what I'm going to do here, because I don't have the x, so I cannot use second trace value. I have to enter another function here at y equal to 0. So you see, here's the second graph. So if we could find the point that these two are crossing each other, these two graphs are crossing each other, that's our answer. So I go second trace, intersect. First curve already is on the first curve. Second, the cursor already goes to the second, and then it says, what is your guess? You're gonna get close to the point that you consider. So we're gonna get close to this one, not the other ones, because it's asking the first positive point. You don't even get close to this one because it is negative. X is negative on that side. So you need to consider one of these, and the one which happened first is this one. And when you enter, it's going to give you the exact value, 0.87 seconds. So when time for t is 0.87, the distance is 0, which is on the surface of the water. Now, is it going down or coming up? Let's see. As you see, the point was under the water, and now it's coming out of the water. So coming out. Just look at the graph and find the direction. Next question says, when was the point 10 feet above the surface for the third time? So this time I'm going to look at this. I want to know when the y, the distance is 10, what is the x? So I'm going to go here and enter the second function as y equal to 10. So you see, this will be the graph. These are the points. All of these are the points that are being repeated. And for all of them, the distance from the water surface is 10. So it's asking us what is the point 10 feet above the surface for the third time. So this is the first time, second, third. So we're looking for this one. So again, we're going to go second trace, intersect, which is number 5. First curve automatically is on it. Second curve automatically goes there. Now, what is your guess? You're going to move the cursor to the one that you want to know the x value of that point. Enter. Make sure to press enter, because if you don't, it's not going to give you the exact value. And it's 17.52. So when time is 17.52 seconds, the distance is 10 feet above the water. And we can say if it's going up or down. So it's coming up. It's not going down. Down is this side, up is this side. So this was the first problem that we did together. You can work on the others on your own. Make sure to read the question perfectly and then highlight wherever you think is important and use them to graph your function. Have a great day.